Dun, 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 dun. Welcome to the second part of 7.3. We are going to keep on going with some examples here. I'm going to do this one a little slower just to make sure all the details are in. And let's go with it here. So we started off 7.3 on Monday. So we were looking at 3 different equations and 3 different variables at the same time. So the question, how in the world does that work? How can we solve for them? 7.1, we did substitution method, is that right? 7.2, we did elimination method. And now we're introduced to something called row echelon form method. Or another way to say it is Gauss elimination.
Oh wait, is this like the same Gauss as the one that like pioneered like you know the theory of magnets?
Ooh, I'm not sure. I would imagine so. Frederick, I don't know if it's Carl Friedrich Gauss, if that's the same guy. Yes.
I think that's the same.
He was mathematician, but I did not know that he did stuff with physics. Because my book in college, which was the history of mathematics, did not include other stuff that these people did. And we found out later, like, oh wow, this guy did this too. That's cool. Anyways, let's go. Let's get started. We'll kind of put things up. And let me give you maybe a list of things to do. We good? As we do this here. So processes here. So first things first, first process is move. Maybe that would be a good thing to do. Just kind of think about this. Move equations around so that x has a coefficient of 1 is the top equation. Ooh, little chicken scratch here, I'll read it for you. So move equations around so that the x that has a coefficient of 1 is the top equation. So interested in this little piece right here. Dylan, question, go.
This is, I apologize because I wasn't here earlier. This is the formula for solving what sort of equation?
This is a process called row echelon form. Let me write it over. So row is the form that we're using. Okay, the other way to write it is to say Gauss. That's how you spell his name? G-A-U-S? Or J-G-U-A-S?
G-A-U-S-S.
Perfect. Okay, Gaussian elimination. What an... Sounds like almost like a garbage machine, right? Elimination. Gaussian elimination. Okay, guys, let's go with it. So first things first is the first equation on top has to be the one that has the x, and it has to be x that has a coefficient of 1. Do we have that already? Absolutely. Okay, step 1 is done. Next is we're going to start writing the next interval here. So first things first, since that equation is all done, we write it over here. Okay, good, good.
This is a process for solving for what?
This is a process solving 3 equations and 3 unknowns at the same time. So next is what we're going to do is we're going to take the first 2 off to the side. And we are going to fundamentally change the second equation. We're good? But we're going to do it by elimination. So question is this. The top equation does not change. The bottom equation has to be multiplied by -1 because that will cause x's to be opposites of themselves. Remember that multiplying through by a number or multiplying through by negative doesn't change the equation at all, right? It's still the same, we call it the same, what do we call it? equivalent equation, right? Has the same solutions. So this guy, notice on the side, it's x plus y plus z equals 3. Great. This is negative x plus 2y minus 4z is equal to negative 5. And then we add them up. Hey.
And there was a cop behind me, so I had to kind of go slow.
For sure.
Slow. Not
I know I was going like 70-30 when I could have been going 80.
slow.
Add this up. What do we get here? We get
So 3y minus 3.
perfecto. Okay, so now this guy becomes our next equation number 2. So this guy rolls into right here. 3y minus 3z is equal to negative 8. Okay, are we good?
Wait, isn't it negative?
Oh, we're adding. Okay, negative 2 is better. Thank you. Thank you for keeping me honest here. Okay. Okay, next is, so notice I want the 1x on front, and then I don't want any x's underneath at all. That's my job. Okay, so then I noticed this. I noticed that, whoa,
That's my dad.
no problem. You want to step out to get it if that's an emergency? Go for it. Okay, notice that the third equation doesn't even have an x over here. So that's cool. So that just comes down. No need to do this little process of eliminating. We just bring it straight down. Da-da-da, da-da-da, da-da-da. We're good? So x's are gone. X's are taken care of. Nice. I like that because that's nice. So next we move to the y's. So now we're stuck with the second equation, trying to figure out how to get rid of this guy compared to this guy. So let's do this here. I'm going to have to go to the next slide. This first equation remains the same. So we rewrite it again over here on the bottom. So x plus y plus z is equal to 3. No problem. The second equation now gets written down. And I wonder if it's needed. So next equation is 3y minus 3z equals 2. 3y minus 3z is equal to 2.
Negative 2, right?
Negative 2, thank you. Okay, so now before we write down the last equation, we want to get rid of the y values. So off to the side, we're going to do the same process over here now. So this goes over here, this goes over here. And I need to, it doesn't matter which one you multiply to get them opposites, it's okay. So I'm going to leave the top equation the same. I'm going to multiply the bottom by negative 1. So 3y minus 3z is equal to negative 2. This guy becomes negative 3y minus 4z is equal to negative 5. Are we good there? Bless you. Add them up. The y's are gone as planned. I like when things become as planned. Negative 7z. Are we good there with the negative 7? So this becomes our last equation here. So negative 7z is equal to negative 7. So Gaussian elimination, nothing. Say again? Oh yeah, absolutely.
I think I might have missed a bit in responding to that.
Sure. It is a long process. That's the problem here. Yeah. So Dylan, tell me where you got lost.
I think
This.
I got lost at as you were explaining, how you got from x plus 1 plus z plus 3 to, you know, the other forms.
So we were here. This top equation gets written down again. So notice it's the same equation, nothing changed. Then we look at the y values. The y values, this guy has a y in front, everything's fine. We can write this one down as well. So we can write this one down underneath. So no changes there. So now what I want is I want to get rid of anything that has a y underneath this guy. So this little guy needs to go. And so what we do is we multiply this bottom equation by -1. And it eliminates the y value as planned. Now I have just a z by itself. And that becomes our third equation. So -7z equals -7 becomes this equation right here now. And we'll do another one as well, just to sort of get, it's gonna, we deal with the process in mathematics, it deals with a lot here. So the book wants you to do this. The book wants you to do one more thing. It wants you to rewrite this, but this little z value, it wants it to be solved for. So this little guy right here, off to the side, you say to yourself, how do I solve this guy for z? I just divide through by -7. That becomes your final third equation right here. Okay, how are we good there? Dun, 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 dun. It is a long process.
Now we start solving, right?
Yep, and now we're ready to be, it's kind of like the beginning of the end. Huh. Dun, dun, dun. See, like Isabel, she has her whole desk covered in stuff. Trying to solve the equation. Camille, how you doing? Hey. That's awesome. That's so cool. Good job. Okay, let's begin. Let's begin with the beginning of the end now. So z is equal to 1. Got that. So let's go up the ladder here. So 3y minus 3 times 1, because that's z now. Let's solve for y. Let's see. That's going to be -3. Ooh, fractions on our hands now. Is that a 1? Do we actually get a 1/3 now? Oh, bummer. Okay. So I got my y value now. Now let's plug back into my original equation. So notice I started with the bottom equation right here. I went up the ladder to this one. Now that I know x's and y, now I can plug into the top equation. So I don't know what x is. I know y is 1/3. I know z is 1. And it should be all equal to 3. What do you guys say? Abe, how would you solve this guy? Easiest way.
I would just add them together, so it's 1 1/3. Then subtract 1 1/3.
1 1/3? Okay, and then let's see if you guys can do that in your head. What is 3 minus a 1 1/3?
1 2 2.
Okay, I'll go with that. And done. Whew, and fractions on our hand. That's no fun. Okay, one more just to practice maybe, and then we'll get into the more interesting things. Okay, this is example 4. Example 5. One more practice. Let's jam just to make sure we get it here. It is 2x plus 4y plus z is equal to 1. X minus 2y minus 3z is equal to 2. X minus plus y. Okay. Dun 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 dun. Dun 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 dun. Whew, okay.
Well, that's why these homework sections have like 4 or 5 problems each, and each one takes like 10 minutes.
Yes, it would be not very nice of me to give you a whole bunch of these.
One would be to rewrite the thing so that x has a coefficient of 1 on.
So we can flip them around, and you want to use the most easiest simple equation. So I'm gonna,
Bottom one.
yes, I'm going to take this bottom one and I'm going to make it the top equation. We good? So first things first is this one, x plus y minus z is equal to -1. And it doesn't matter which direction the other two go. So this is 2x plus 4y. Okay, so first step one has been accomplished. I have the easiest equation on top. X has a coefficient of 1. In fact, yeah, let's do it the way the book does it here. So next is I rewrite the top equation. I'm going to use the top equation to start getting rid of the other ones as I go through it here. So let me do this I'm going to flip between the two slides. We're good? So x plus y minus z equals -1. Okay, we're good there. It'll be a long process here, but we'll get there. So before I write down the next one, I'm going to take this equation, I'm going to multiply it by -2, and I'm going to scoot this equation over. We're good? I'm going to create a modified equation 2. So how about -2x minus 2y plus 2z, and you guys make sure I multiply correctly here. So I use the top equation, it's the easiest equation. Even though on the previous one, I used the bottom and I multiplied, right? Let's always be manipulating the top equation as we go down. Okay, question is, do I get rid of my x's? Done. Next one is 2y plus what, 3z? Does it go to 3? Are we good there? We're gonna stick this as our new equation number 2. Let's jam, so off to the side. I got myself 2y plus 3z equals to 3. Okay, my new equation done. Are we good there? Okay. But then I have this other one as well. So I got to do another one. So let's do this bottom equation multiplied by -1 to get rid of this third equation. Are we good there? Negative x minus y plus z is equal to 1. And the bottom equation stays as is. Ooh, okay, a little bit of space here. I'm going to try to get it. Hold on to you guys here. I'm going to wait for you guys to catch up. Dylan?
So this method revolves around moving the order in which you solve the equation.
Yeah, so the first step is to get the x that has a coefficient of 1 on the top equation. Step 2 is multiplying. Let's do consistent here. We're going to multiply this by some kind of value in order to create opposites for any variables underneath, and we add them up and create new equations for those. Negative 3y, is that right? Let's see, plus, oh no, minus 2z is equal to 3. Are we good there? All right, you guys talk to me here. Did I get minus 3y? Minus 2z is equal to Okay, next is the easiest way to do it would be to see if something has a y to the coefficient of 1. And we're going to scoot that in as our second equation. But in this case, none of them have it. That's no fun. That's still okay. Top equation is done. No need for the top equation. We've done that already. This is the next set here. And we're not going to change equation number 2 anymore. Because now we're setting up for all the y values. That's what we're setting up for. So this guy stays the same now. This is 2y plus 3z is equal to 3. What we want to do is we want to get rid of the y value underneath here. So what should I multiply by to get opposites for my y values?
3 and 2.
That would be perfect. So let's see, 6y plus 9z is equal to 9. This one is negative 6y, exactly what I wanted here. Negative 4z is equal to 6. Everybody in agreement there? Add them up. The y's are gone as planned. And I got myself a, is it 5z is equal to 15? Yes, okay. Let's do this because it's a lot easier. Once we get to z, it's a little easier. Can I just divide by 5 over here already? Instead of multiplying and then rewriting the whole thing over again. So it's got z is equal to 3. That's my now third equation. Z is equal to 3 is perfecto. All right, now we have the beginning of the end, right? This is true, and if that's true, then 2y plus 3 times 3 would give you 3. And we start working backwards now. Let's see, that's going to be 9, negative 6. Perfect. Are we okay there? Working backwards, this is the easy part. So now you just work backwards to the end. And then rewriting the top equation now. It's going to be
Wait, isn't it -9? I think? -3 -9.
Huh.
Sorry, no, -3.
Is that okay?
Yeah.
Yeah, it's this one. Yeah, just the signs change here. So x minus 6 is equal to negative 1. Add 6 to both sides. Are we okay with 5? Oh, we forgot to write the answer last time for this one. It's always going to be x, then y, then z for our final answer. So 5, negative 3, positive 3 is the solution to all of these guys. Okay, are we good there? What we really are doing is we're actually finding these guys here are no longer lines. Let's talk about what it means here real quick here. These guys here are no longer lines for us. These guys are actually like sheets of paper in three-dimensional space. We call them planes. You guys remember doing plane geometry? Plane geometry just means, oh yeah? Plane geometry just means you're doing it on one single surface, right? You draw a triangle and it's on that surface, right? Like on a desk, that would be plane geometry, right? But think of your desk as a sheet of paper. We good? And think of these guys as are sheets of paper in three-dimensional space. And so what we just did is this. In three-dimensional space, we found when this plane right here intersects with this plane here, let's say it goes like this, and I should go like this. That's one equation right here. That's a second equation. And what happens is this right here came a third equation. Totally on the backside. And what happened was we found out that the point where all these three intersect is called 5, -3, 3. It's a certain point in three-dimensional space that these guys all hit at the same time. Good example, maybe. Let's do this here. Let's do our ceiling right here, right? Our wall on this side and the front wall of the room. Those guys intersect at exactly one dot. Yeah, like right over there, huh? Just that little piece right there. It's a one little piece in space to intersect. But hold on though, got another little question. If I had that wall, the other wall of the room, and the ceiling, are those guys ever going to intersect?
Not all at one point.
Are they going to intersect? No, there's actually never a time where, especially because those two are parallel from one another, right? That wall and that wall are parallel. They're never going to, that's going to be a no solution in our case, right? Then there's one time where it's kind of funny. Let's do this one real quick here. Let's say one wall of the room, this wall over here, on the ceiling. So one wall, one ceiling, correct? And these are planes, right? That's the wall in our room. That's the ceiling in our room. And let's say we had a sheet of paper or a plane that was cut like this, right into it like this. It went diagonally across. It just kind of went down like this. What's the intersection of these three planes? Kind of weird to imagine here, but think of
It'd be that whole line, right?
Oh, yes. Everybody okay with this? So it'd just be the length of the room itself. Is that okay?
So that's how you get infinitely many solutions.
All right. There's my infinitely many solutions. Whew, okay, are we good? So now let's tackle the weird stuff. And Camille, since she was not here Monday, now she's totally like, whoa, this is weird stuff. So with X, Y, and Z, you now don't get lines, you get planes. Planes intersected each other still at one point. None if they're parallel to one another. Like this right here, right? These guys will never intersect with each other. So there's no solution. And then sometimes it just very, very specifically, they will hit each other right at the exactly perfect line. And so there you got infinitely many solutions. Let's try it. Let's see what happens with these guys. Yeah, I think we have just enough time. We are at example what?
Should be 6.
Example 6. Okay, these are the weird ones. Let's go for it here. X minus 3y plus z is equal to 1. 2x minus y minus 2z is equal to 2, and x plus 2y minus 3z is equal to -1. Okay, 2 examples here to finish off, and let's see how we get it. All right, so first things first, do I have a coefficient of 1 for the x in my top equation? Yes, love it. That's cool. All done there. This gets me x minus 3y plus z is equal to 1. Now to get rid of stuff, to get rid of these two right here. So let me actually go up like this, and then we'll, let's see, I'm going to multiply the top by a -2. That'll create opposite for the +2 down there. So -2x plus 6y minus 2z is equal to -2. This guy stays the same. Better to multiply just one equation than 2. And what do we get as our new found equation 2?
4G2.
I would go with that. Hey, I think you guys are slightly getting the hang of this. This is good. Okay, so my new equation, new bottom equation is, or new middle equation is 5y minus 4z equals 0. Everything's good there. So now let's do top equation versus bottom equation. And I'm going to multiply the top equation by -1 this time. So -x plus 3y minus z is equal to -1. Dun, dun, dun. Bottom equation stays the same, but hopefully we'll get rid of it. Boom, boom. Now, what is my new found third equation?
5y minus 4z.
Minus 4z is equal to -2. My new found bottom equation is 5y minus 4z is equal to -2. Yeah, hold on. So you should kind of notice something. You can't, that's weird. You can't have the same equation with variables equal to one number and then the same equation with variables equal to another number. Something's going to be off. But notice we're just going to do the process. So do I have x and did I eliminate all the x's underneath? I sure did. Okay, so now let's keep with the Gaussian elimination process. So I'm going to create a new third equation, right? My top equation still stays the same. So it's still x minus 3y plus z is equal to 1. My second equation remains the same as well, because that's what I found. Cool. Now I'm going to use, do I have space here? Yeah, I have space. I'm going to use these two. So I'm going to multiply the top by -1.
I did not get a happy answer for that.
0. 5y minus 4z is equal to -2.
0 equals -2.
Okay, whenever you get this, anywhere along the line, whenever you get to the point that this is a false answer, it is not true, we can stop there. And we say, no solution. You good? There's never a time. It is impossible.
We have to check later once we saw that they go to and like 4 is 5y minus 4z equals 0 and 5y minus 4z equals -2. Because we have stopped there.
You technically can, yeah, at that point. Okay. We call this later on in mathematics, we call it an inconsistent system. If you guys can write that in there. So inconsistent system, well, not solution, system. Because eventually what we do is we talk about different, this is a system of equations, right? We talk about different systems. Inconsistent systems do something. So this is the no solution. Okay, we're good there. Example 6. I think I like this. It's like the upward arrows going up and then we got downward arrows going down. Okay, don't even need to do this. If you wanted to, you can kind of write this right here and then say slash right to the equal sign. You could do it that way as well. Cool, okay, there's a little bit of time left here. Let's jam with exercise 7 the other way, the other one, just to go a little bit faster. This one's gonna be a little bit of a sneaky one here, so let's talk about it. Ooh, and then what I'm gonna do, I'm gonna give you some missing variables here. So part towards the end of the homework, you're gonna see missing variables, and that's okay. We're just gonna work with this, the fact the way it works. So first question is, do I have an x, the top equation that has a 1 for the coefficient? Yes, I do. Everything's great. Rewrite the top equation as is. All right, this guy is going to be infinitely many solutions, not because it's missing variables, but just because the numbers work out that way. We good? Just so you know. Okay, second thing is, do I have I eliminated all the x's underneath it? The second equation did work, right? So I could just write the second equation. No need to eliminate an x if it's not even there. That's cool. So we just do that. But this one right here, got to eliminate that guy. And they're already opposites. That's cool. So no change for the first equation, no change for the third because my opposite's already sitting there. And this is negative x plus 2y is equal to 1. Okay, so let's add this up. And what do I have? I have x's are gone. I have a 3y minus 3z is equal to 0. That's okay, cool. I've made my third equation. All right, so question is, have I eliminated all the variables
That's interesting.
of x's underneath the x? Yes, I have. That's done. So now let's move on to the y value. So the big step 1 is done. So let's do this here. Let's rewrite the top equation right here. That top equation is just x plus y minus 3z is equal to negative 1. The second equation works as well. Y minus z is equal to 0. We're going to create so that equation gets copied. Actually, these two equations get copied. We're going to create a third equation, a new third equation. You guys ready? What should we multiply the middle equation to get opposites? Negative 3. Dun, 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 dun. So negative 3y plus 3z is equal to 0. Our third equation does not get changed at all. And here's what I see. I love it. Okay, if you see this on your hands, you have infinitely many solutions. But we don't stop there with this guy.
We don't.
Okay, good. Because remember like the side wall that we had, right? It was the wall, it was the ceiling, right? And it was this little extra sheet that came in here. This guy is actually a line, right? There's a line connection to it. So that means if I plug in a certain value for A or a certain value for Z, there's a connection between the Y, there's also a connection between the X's. So I needed the equation of a line, but we're going to do it a little differently. So here it is. So first things first, notice that the last equation got eliminated, right? So technically, we're just down to this right here. Good there? So what we're going to do is we're going to start off with our bottom equation now, and we're going to solve for y. And we have to make one of the variables to be a constant, right? So here's what we're going to do. We're going to say let z equals an a value.
So we just plug in a value for z.
Yeah, we're plugging a value for z. So z could be any arbitrary value because we're just trying to get a connection between z, y, and x. And so if that's the case, then we look, now we're going to backtrack again. So if that's true, what's y value going to be? Hey, y value is also a, is that right? If this was what, let's say if this was a connection like this or something like that, right? And we moved it over, then we would have had 2a on our hands. Right? But because y and z were the same, it's the same value. Okay, so then if that's true, then let's go up one more. What's x going to be? Well, let's see, x plus a, which is the y value, right? Minus 3 a's gives us a negative 1. It's minus 2a. Add 2a to both sides, is that right? And I like to put the positive one in front. So there it is, there's my connection there. And right on time. So here it is, my connection between the three values are a goes in for z, a goes in for y, and it's a 2a minus 1.
So that's what we'd have to show at the end.
That's what we got to show at the end for these guys. So infinitely many solutions require a little bit more work to put that in. And we're gonna have to show that relationship between the three of them. Okay, and done on time. Look at that, to the second.
Oh, thank you.
Uh-huh. Guys, have a good day.
I should probably staple it.
Okay.